Hi guys, so what we're looking at here is my Commodore PET model 8032. This is in lovely condition, and the video that I had lined up for this was going to be a video fixing the IEEE port. So the IEEE port on these is the port that you connect to a disk drive, an external disk drive, and I bought an SD card converter for this machine. So this device you plug into the IEEE port and it will replicate a disk drive, and it actually takes a memory card in there. Now, I bought this Commodore PET as a working machine and everything was working fine with it, but when I came to plug in the interface, what happened was it just didn't recognize it, and I was given online some instructions, some lines of code to put in to test the port, and it looks as though there is a problem with some of those ICs. So I bought the chips, bought the chip holders, got everything ready to do the video, and the thing went bang. I switched it on and I heard this loud bang from inside, and I believe that it's the filter capacitor. I've not looked at it yet, I've not taken it out. If I just open this up, we'll take a look inside. So this is the inside of the PET. Got the main board here, circuitry for the monitor is up there. The power supply is a linear power supply. All of the rectification and the regulation is done on the board. So the AC lines come from the transformer into the main board. There's some rectifiers and there's some regulators on these heat sinks here. The voltage rails, the main voltage rails, the 5-volt rail actually comes back into this filter capacitor and then back onto the main board again. Now, there is, I believe, a filter capacitor underneath the linear transformer, and I believe that's what's failed. There's no power to the transformer itself. So the mains comes in, goes through a fuse, goes through the switch, transformer, and there's no power going to that transformer. So something's happened between the socket at the back and the transformer, and the only things in there are the power switch, the fuse, and this filter capacitor that's in there somewhere. So that's what this video is going to be about. I'm going to take the power supply out, we'll have a look at that filter capacitor, and we'll see what's happened to that. Hopefully, if I can get this working, we will proceed on to another video in the future which will fix the IEEE port. You might be able to see on the edge connector at the back of the board here, this is the IEEE port, just at the back there, and there's some chips which are associated with that port. So like I said, I've bought the new chips, so we'll hopefully run some code, see the faults, and then we hopefully be able to diagnose which chip is the problem here. But for this video, it's going to be a power supply repair video. So let me readjust this camera and we will take out the power supply. So as you can see, this case lifts up rather like a car bonnet to reveal the inside. Now I think I can run this all the way down and get good access to this power supply here, so that's what I'm going to do. I think this needs to be unbolted. Looks like it comes complete with the power socket and the switch, etc. Let me just show you around the back. So the back of this, you can see there's the power input, we've got a fuse, we've got a power switch. This is the back of that connector for the IEEE port that I was talking about. So it looks like there's just a couple of bolts here, maybe there's a couple underneath, and we can take out that whole power supply unit and take a look. So what we've got is a socket here, so we can take this off the main board. I will disconnect this capacitor, I'll take these ties off, that should release it, and then the only other thing connecting the transformer to the case is these two wires here. This is the power supply for the monitor, so this is separately rectified and regulated in the monitor circuitry, so this is just an AC supply to the monitor. So I'm going to unsolder these off the transformer. So I believe this machine, this particular model, is from around about 1983. There is a date on a ROM chip here that says 79/80, but I believe that the machine itself is about 1983, maybe 1982. But it is in very good condition, cosmetically very good condition, and inside here it's very clean. There are, I've seen a couple of these machines inside. I've owned one before, and the condition inside was pretty poor. Had a lot of repairs done on it. Obviously somebody had unsoldered a lot of chips to try and diagnose what the problem was. This, let me just get a bit of solder on this iron. It's old solder, might need a bit of help just to get that loosened off. One more black cable coming under here. I expect that is a ground wire somewhere. Let's see if we can release that. There's quite a bit of weight in this transformer. Yeah, there is a ground connection bolt onto the chassis. It's underneath the main board. So this is going to be easier to take out the main board. It's very simple to get this out. Everything's socketed, so there's nothing difficult there. There's two sockets here, one for the keyboard, one for the monitor, and then there's just a few screws in the board itself. couple of these plastic clips. They just squeeze together. Should be it. Okay, I can show you that earthing clip now. There's the earth clip just there. So there's a earth wire going to the monitor chassis by the look of it, and then this one here, this goes directly into this box here on the power supply. So I'll just take this off that earthing clip, and then we can take a look at this. This is the power supply out of the machine. This is the entire thing. So linear transformer, mains input, switch and fuse are all built into this section. And I suspect that this is the filter capacitor. Probably a class X, maybe a class Y, maybe both. So yeah, I did hear a loud bang when I turned it on when this fault occurred, so I was expecting to see this ruptured in some way, but it is a metal can, so perhaps it's happened internally. But we'll take it out and we'll take a look. So we can see there that cable grip isn't working very well. We can see the mains input here. Let's have a look how that filter is wired. So there's 4 wires coming off the filter, 2 blue and 2 black. Okay, let me take a look at this, figure out how it's wired up, and then I will come back. So on this filter, we've got 2 blues and 2 blacks, and according to the information on here, I'll take a picture and I'll post it on the screen. It says that we've got 3 capacitors, so we've got one 0.1 microfarad and 2 2500 picofarad. It actually says XY after that, so whether that means they dual purpose, could be X or Y, or perhaps one of them is X, perhaps the 0.1 microfarad is X and the 2500 picofarad is their Y class. And then we've also got 2 100 microhenry inductors, so that will be for interference suppression. So I have measured the input and output on this, and something is broken inside here. So this is actually first in line from the main supply, and the switch is after this. So I'll draw this out on a diagram for you and I'll show you what I suspect is inside here. So our filter here, we've got 2 blue wires which are connected directly to the main supply, directly to the mains cord coming in, and then we've got a black, 2 blacks coming out. And one of these blacks goes directly to the transformer winding, the other one goes through the fuse, the power switch, and then onto the transformer winding. I've checked the input to this, so we should have a current path between the blue and a black and the other blue and the other black, and I don't. It's basically all of these are isolated. They're all open circuit. So whatever's happening to the power supply is inside this can. There's also an earth connector here on the edge. So I'm going to draw a dotted rectangle here, which is indicating everything that's going on inside that metal can. We've got two blue wires coming in, and they're directly connected to the main supply, so live and neutral. And then we've got two black wires coming out. This one then goes through the fuse and the switch. And after this, it's directly connected to the transformer winding. So putting mains on here and not getting mains here, something is going on inside here. Now there's we know that there's two capacitors. I assume the two that are the same are going to be Y class, because two of them would make sense. Y class go between ground and a line, so one between ground and neutral, one between ground and live, and the other one I'm assuming is an X class, which would go between the actual incoming lines here. So let's draw this out, see if we can figure out what's happened. So first of all, I'm going to draw in the X class, so that will be there. Let's draw the Y class, so there'll be an earth connection. That's the tab on the case that you saw. That would then have Y class there and a Y class there. This is an X. Okay, and there's also two inductors. So the inductors, they could be here or they could be here. Let's draw them in here. And another one there. So inductor. Okay, so this is what I'm expecting is in that case. For there to be no path of current between here and here and here and here, I can only assume that these inductors have failed, and failed in such a way that they've gone open circuit. That is what I'm thinking has happened here. So if they have gone open circuit, and it could be the same inductor, of course. It says two inductors, but they could be part of the same, they could have the same core. So, yeah, I don't think anything in here, well, I know that nothing in here we need. Nowadays, there's not so much of the sensitive radio equipment that everyone had back in the old days. The wireless sets, the valve radio sets, they were quite sensitive to any kind of electrical interference. You can at least test it without this in the circuit and see if it powers back up again. I'm sure I could buy another filter if I wanted to put that back in there. So let's take this out. Let's bypass this and see if the thing powers back up. Power supply is back in the case now. I have tested this, I've powered it up, and with the monitor attached I can see the monitor working. I haven't put the main board back in yet because, as I said, I want to do that repair on the disk drive port. So the power supply is fixed on this. It was just this filter that was causing the problem. I have noticed that on some pictures that I looked on the internet, this red part of the filter there, that's not supposed to be showing. This has actually been pushed out. So I think when I heard that bang, whatever's happened in here has blown out the side. There's a bit of scoring on there. I might put another picture on here just to show you what that looks like. But yeah, something has obviously failed in here. Now I've just removed this at the moment. I've just bypassed it. So this this choke and the filter, I've just bypassed. So the mains just go straight into the transformer, which is fine. I mean, from a operational point of view, it's not going to cause any problems at all. It's like I said, it's just for RF suppression on this machine. So I may put some capacitors back in there when I get hold of them. So it's back up to the spec that it was. But yeah, you can just take this out and bypass if the same thing happens to yours. So yeah, that is it for this video. Only a short one, but I believe that this is a common issue. After looking on the internet, these filters do fail quite often. So it's it might be useful for somebody who wants to fix that power supply up. I will make another video of the disk drive port. I'm not sure when that'll go up, but yeah, I'll do that, and I will link this one in. So thanks for watching. If you like the video, please give it a like, and I will see you on the next one.